Hi, so this is Professor Maley. I'm creating a video around Boxplots. Um, so we're going to look at how to create Boxplots and also answer some questions about Boxplots. And then at the end, I also want to be able to match up Boxplots with an appropriate histogram. So this first part, we're going to create Boxplots. So I have three examples. The first one's more basic, and then we'll get maybe a little more difficult, right? So if we look at the first data set, one thing that you'll notice is that's not in order, right? From smallest to biggest. So that's the very first thing that we want to do is to rewrite this in order, right? So this would be what 1, 6, 8, 9, 12, 15, 16, 18. Right? So then the other thing I like to do is just know how many pieces of data I have. I have 1, 2, 3, 4, 5, 6, 7, 8. So n equals 8, right? My sample size is 8 in this case. And then so what we need to find are the following, right? We need to find the 5-number summary, right? So that's the minimum, quartile 1, the median, Q3, and the maximum. All right, so remember I said this. These are referred to as the 5-number summary. And then we're also going to want to find the interquartile range, the lower fence, and this is sometimes I refer to that as the left limit, right? So that's the same idea. Then we have the higher fence, which sometimes I refer to this as the right limit, right? So this is like the left limit, and this is the right limit. And then we're going to want to identify any possible potential outliers. Right? So minimum is pretty easy to find. And my minimum is going to be 1. Right? That's my smallest number in the data set. My maximum is 18. Right? And then to find the median, I'm going to average the two middle numbers because we have an even number in our data set, right? So my two middle numbers are 9 and 12, right? I have 3 on either side. So to find the median, I'm going to take 9 plus 12 divided by 2, which is what, 10.5? Right? So then to find quartile 3, or excuse me, let's find Q1 first. In order to find quartile 1, we're going to, know right here down this line, that's where my median is going to be located. So we're just looking at the numbers to the left. We want to find the median in the lower half, right? So from the minimum of our data set up to that line. All right, let me just make this a little neater. Right. So I have two numbers in the middle, 6 and 8. So to find Q1, I'm going to take 6 plus 8 divided by 2, which is 7. And then for quartile 3, same idea. We're just going to the left of to the right of the median, right? Looking at the upper half of the data. We need to average these two numbers, right? So Q3 is 15 plus 16 divided by 2, which is 15.5. Right? So then we can find the interquartile range now. Remember, IQR is equal to Q3, quartile 3, minus Q1. So we would have 15.5 minus 7. So 15.5 minus 7 is 8.5. Right. So then the lower fence, right? Remember the equation for this is we take quartile 1 minus 1.5 times the interquartile range, right? And the upper fence, oops, I don't know why I wrote higher. Typically we say upper, sorry. Right, the upper fence is quartile 3 plus 1.5 times the interquartile range. So quartile 3 is 15. So we fill these in now. Quartile 1 is 7 minus 1.5 times 8.5. And the upper fence is 15.5. Right, just plugging in these data values. Plus 1.5 times 8.5. Right? Something to keep in mind is these lower and upper fences, they never appear in your box plot, right? The whole idea with those is that they're a line in the sand to help us identify what are potential outliers, right? Because outliers are going to, remember, show up as like a circle on the box plot, right? So if we just do some arithmetic and simplify these, so 7 minus 1.5 times 8.5 is negative 5.75. And then 15.5 plus 1.5 times 8.5 is 28.25. Right? So, in other words, any number bigger than my upper fence is going to be an outlier, right? Well, my maximum number is 18, so there are no values bigger than 28.25, so I don't have any outliers to the right. And then any number that's smaller than negative 5.75 is going to be an outlier. But my smallest number is 1, right? My minimum is 1, which is greater than negative 5.75. So I don't have any numbers less than that. So in this example, there are no outliers. All right, so I'll just write no outliers. Right? So if you need like kind of like a visual, so like here's a number line. Here's my lower fence, negative 5.75. And then here is my upper fence, 28.25. So all the numbers in between here are good, right? They are non-outliers. Right? Everything in between here. Where if I pick a number that's to the left of negative 5.75, or if I have a data value that's to the right of my upper fence 28.25, then these would be outliers. Right, so that's what I meant by these numbers are just kind of like lines in the sand to help us identify what are outliers, right? So in this case, we have no outliers. So something to remember when making a box plot is we need to have a number line, right? So don't forget always to have a number line when you make a box plot, right? We need an x-axis. And here my minimum's 1, my max is it is 18. So I'm gonna go up by 2's each time. So start at 1 and going up by 2. Right. And then what I like to do is construct the box first. So let's draw a line where the median is, which is 10.5. So it's going to be roughly here. And then draw a line where Q1 is, which is 7. and then draw a line where Q3 is, which is 15.5, so roughly here. And then we can construct our box. Right. And then my whisker is going to go, my left whisker is going to go to the smallest data value that's not an outlier, right? So that would be 1, right? Because since I didn't have any outliers, it's going to go to the minimum. So this is going to go all the way to 1. And then my maximum is going to go to the biggest number that's not an outlier, which in this case is my max because it's not an outlier. So that'd be 18, right? And then something I like to do is label where each thing is. So like above the left whisker, we stopped at 1. Q1 is 7. The median is 15.5. This was Q3 was 15.5. Wait. Yeah, median was 10.5. Sorry. Q3 was 15.5. And then the maximum where we stopped the right whisker was 18, right? So I just kind of like to label those just to make it clear what those values are. Right? So that's how to make a box plot, at least the most basic example, right? So then the next two, I already put them in order from smallest to biggest just to make it a little easier to work through, right? So the first one I did out of order intentionally just to remind you that we need to put things in order so that way we can identify, the median and quartiles, right? So these ones are already in order, but we still need to find the same things, right? I'm going to need to find the minimum, Q1, the median, Q3, the maximum, the interquartile range, the lower fence, and the upper fence, and any outliers. Right. So my minimum is 8, right? My maximum is 71. I can fill those in. And then here I have, I think, 10 values. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I need to average the two middle numbers to find the median, right? So there should be 4 on either side, right, to find the two middle numbers. So we want 23 and 26. We want to average those. So the median is going to be 23 plus 26 divided by 2, which is 24.5, right? So then my median is here, right, somewhere in between 23 and 26. So I'm gonna find the median of the lower half, right, to find the quartile 1. So that's going to be 14, right? And then the middle number in the right, the upper half is 33. So Q1 is 14, and Q3 is 33. So then the interquartile range is 33 minus 14, right, which is 19. Right. Then the lower fence is Q1 minus 1.5 times the interquartile range, which is 14 minus 1.5 times 19. So 14 minus 1.5 times 19, we get negative 14.5. And then the upper fence is Q3 plus 1.5 times the interquartile range, which is 33 plus 1.5 times 19. So 33 plus 1.5 times 19 gives me 61.5. Right. So then let me erase values up here, right? So we think about like where the lower fence is going to be. The lower fence is going to be somewhere over here, right? This is where the lower fence is. But the upper fence is in between 39 and 71, right? So that means that 71 is an outlier, right? Because it's to the right of the upper fence. And I don't have any values lower than the lower fence, so we're good. So the outliers we have one outlier, which is 71. Right? So then now I have everything I need that I can draw my box plot. So first thing, we want to get a number line. So I'm going to start, let's start at 0 and go up by tens. Right? So then I'm going to draw a line. Oops, sorry. Right, so now I'm going to draw a line where the median is, so 24.5, so roughly here. And then Q1 is 14, so draw a line there. And then 33, we'll draw a line there. Right, and then now I can construct my box. Right, because remember a box plot, another name for it is the Boston whisker plot, right? Because we have a box and we have whiskers. So then my left whisker, remember, is going to go to the smallest value that's not an outlier, which in this case is 8, right? Because there are no outliers to the left. Right? And then my right whisker is going to go to the biggest value that's not an outlier, right? So if we look up here, that's 39, right? That's the biggest number that's not to the right of the upper fence. So I'm going to stop this right whisker at the value 39. Right, so we're not stopping at the upper fence. Remember, the upper fence doesn't show up in the box plot whatsoever. Right, it helps us identify outliers. So then, since I have one outlier, I need to draw a circle where that is at. Right, so 71, there would be a circle here. Right, and then of course, if you wanted, we could label these. Right, so this is 8, 14, 24.5. 33, that's 39, and this is 71, right? All right, so then have one more example, and this one's a little harder. Here we're going to have outliers to the left and the right, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. We have 14 pieces of data. So we want to find all those parts still, the minimum, Q1, median, Q3, and the max. Right, and then we'll find the interquartile range, the lower fence, the upper fence, and we'll find that it doesn't find any outliers. So we're going to have things in order from smallest to biggest. So the minimum is 2, maximum is 130. So I'm going to want 6 numbers on either side, right? So 1, 2, 3, 4, 5, 6. So these two, 1, 2, 3, 4, 5, 6, right, should be my two middle numbers. I want to average, right, to find the median. So we take 58 plus 59 divided by 2, which gives me 58.5. Right, so my median is, in between here. So then Q1 is 55, right? That's the middle value. And then 70 is Q3, right? That's the median of the upper half, right? It's the middle. So Q1 is 55. Q3 is 70. So then the interquartile range is 70 minus 55, which is what, 15? The lower fence is Q1 minus 1.5 times the interquartile range. So that would be 55 minus 1.5 times 15. So that gives me 32.5. And then the upper fence is Q3 plus 1.5 times the interquartile range, which is 70 plus 1.5 times 15. So 70 plus 1.5 times 15 is 92.5. Right, so these values are going to help me identify outliers. So let me just erase the markings I did on the numbers, right? So the lower fence is 32.5, so that's going to be in between 4 and 5, right? That's where my lower fence is. Then my upper fence is going to be 92.5, which is in between 70 and 120, right? So this would be my upper fence. So all of these numbers are outliers, right? And then I'm going to stop my right whisker at 70, and my left whisker I'm going to stop at 55, right? Because those are the smallest and biggest numbers that are not outliers. So for my outliers, I would list 2, 4, 120, 121, and 130. Right? So then again, don't forget, first thing we want to do is make a number line. So I'll go, I think I'll go up by tens again. So we'll do 0, 10, 20, 30, 40, 50, 60, 70, so forth. Right? So then next, let's draw a line for the median. So 58.5. Right, draw a line for Q1, which is 50, 55. And then I'll draw a line for Q3, which is 70. So there's my box. Right, so I'll just label those really quick. 55, 58.5, and 70. And then my left whisker, like I said, is going to stop at 55, right? Because that's this value here. That's the smallest value that's not an outlier. But notice Q1 is equal to 55. So the whisker has like a length of 0, so we don't actually draw the whisker in, right? And then the right whisker would go from 70 to 70, which has a distance of 0, right? Because 70 is the biggest number here that's not an outlier, right? So the right whisker is not going to show up either, right, in this. So then now I just need to draw my circles to represent my outliers. So we would have one at 2, 4, 120, 121, and then 130, right? So there's the box plot for this data set, right? So probably the hardest thing is just knowing where to draw the whiskers. Right? So now I'd like to look at an example and answer some questions about this. And this is a pretty good worksheet. The only thing I don't like about the worksheet is there isn't a number line at the bottom, right? So there should be, a number line here, where this would be, line up with 60, this would line up with 0. So then, in the middle is going to be 30, and then, we would have, 90, and then, 120 and so forth, right? If we want to go up by 30s or, however tick marks we want to go up. So this number line would fit for both box plots, right? So it's convenient sometimes to do what we call like a double box plot or side-by-side box plot to compare two different data sets, right? So, and one thing you want to remember, right, is that, what the box plot does is show us where the quartiles are, right? So like inside of here, inside between the whisker and the box, there's 25% of our data, right? And then here, in between, Q1 and the median is another 25%. And then in between the median and Q3 here is another 25%. And then lastly, this whisker, right, shows another 25% of the data, right? So it splits it into these fours, right? So we want to be clear about that, right? Remember that, right? So if we look at number 12, in this data, right, you want to be familiar. The data set is for high school students at a specific high school, and they were sophomores, and they were asked how many minutes do you spend on homework per night? How much time do you spend on TV per night, right? So number 12 says what percent of the sophomores watch TV for at least 15 minutes per night, right? So these numbers are in minutes. So if we look at the TV time box plot, the lower one, here's the number 15, right? So remember, there's 25% of my data here, so that means, all the way across, there's 75%. That's bigger than 15 minutes, right? So the answer here would be 75%, right? And then number 13 says, what's the third quartile for the TV time data, right? So quartile 3 is found here, right? So that would be 110 minutes, right? So now, number 14, we're asking, is it more common for a sophomore at this high school to spend more than 1 hour on homework or more than 1 hour watching TV? Explain, right? So let me erase some things here. Right, so one thing you want to notice is that the one, we have data for 1 hour for both, right? They line up. But 25% of the data for homework is above, more than an hour. Where for TV time, this line is the median, so there's 50% above here, right? So what would be more common is for someone, one of these sophomores to spend more than an hour watching TV, right? That's more common because 50% of the students do that, right? Where only 25% of the students spend more than an hour doing homework, right? So let's write this up. So I'm going to type this up here to the right. So I would answer it like this. It is more common for a sophomore at this high school right, so it's more common for a sophomore at this high school to spend more than 1 hour, which is 60 minutes, on watching TV because 50% of the students spend more than 1 hour more than 1 hour on watching TV compared to 25% of the students spending more than one hour on homework. Right, so that's the write-up for this part. Oops, that's not showing up too well. I'll just leave it over here. Right? So notice we're answering the question, we're explaining fully, right? How do we know? And we're stating it in context, right? So that's important, right? You want to be really clear with explanations that you do. So then number 15, so 15 through 23, what we're going to do is label it as the statement as true, false, or cannot be determined, right? So number 15 says some sophomores didn't watch TV that month, right? So when we're looking at the TV data, let me erase here again. So when we're looking at the TV data, notice my left whisker ends at 0, right? So what that means is that 0, remember, is the smallest number that's not an outlier. So that means 0 showed up in the data, right? That's either, since there's no outliers here, that would be the minimum value, right? It makes sense because we can't have negative. We can't spend negative minutes doing homework or TV or doing anything, right? Unless you can go back in time, right? So this would be true, right? Because 0 is my minimum for both homework and TV time, right? Number 16 says the TV box and whisker graph contains more data than the homework graph, right? So they're thinking that maybe there's a bigger number of students, right? Bigger N value for the TV box and whisker compared to the homework, right? And that cannot be determined, right? So it cannot be determined because box plots don't tell me anything about like frequency or how many what's your sample size for the data, right, for each variable. That's not what it does, right? It tells me how gives me some information about how the data is kind of distributed but cut into force, right? And also it helps me identify outliers pretty easy. So we can't answer a question about like how many of something there were, right? So number 17 is 25% of the sophomores spent between 48 and 60 minutes per night on homework, right? So if we come up here to homework, here's 48, here's 60. So that would be true, right? Because in between the median and Q3 would be 25% of the data. So that's true. 25% spent between 48 and 60 minutes per night on homework. And then number 18 says 15% of the sophomores didn't watch TV that month. Well, that cannot be determined also, right? Because we don't know 15%. We're cutting into quarters, right? Quartiles. So we have we can maybe make some statements about 25%, 50%, 75%, and so forth. But we can't do like in between like 15%. We can't answer that just by knowing the box plot, right? And then number 19, it says, in general, though these sophomores spend more time watching TV than doing homework. So if we're talking about a typical value, right, a value that we'd want to compare for the typical value is the median, right? So I'd want to compare 48 to 60. So the statement says, in general, these sophomores spend more time watching TV than doing homework, and that would be true, right? Because the median, which is the typical student's going to spend 60 minutes on TV time per night, and that's greater than 48 minutes, which is the typical time that a student would spend on homework, right? So compare the medians to get a general sense. So that would be true. 20, the TV data is more varied than the homework data, right? So to talk about variance of a box plot, we're thinking about the interquartile range, right? And visually on the box plot, remember that this distance between the box, that's the interquartile range, right? Because the interquartile range is Q3 minus Q1, right? So for homework time, the interquartile range is 40, right? 60 minus 20. And then for TV time, the interquartile range would be 110 minus 15, which is 95, right? So that would be true, right? The TV data is more varied. The interquartile range is higher, right? So that's true. There's more variance, right? There's more spread. So in other words, my homework time data is like their values are closer together, right, in a sense. So then 21 says the ratio of sophomores who spend more than 110 minutes per night watching TV to those who spend less is 2 to 1. Right? So let's take a look at that. So what we're looking at is 110, right, for the TV time. So there's 25% of the data to the left or to the right of this, and then to the left there's 75% of the data, right? So what we're doing is making a ratio of those who spend more to those who spend less, right? So in other words, we'd have 25% to 75% would be my ratio. But notice my ratio, they have it in terms of whole numbers, right? Like they have whole numbers listed there, not percents. So what I could do is divide both sides by 25%, and that would make this be 1 to 3, be my ratio, right? And that's not what the ratio they provided, which was 2 to 1. So this would be false, right? So the correct ratio would be 3 to 1. So that's false. And then number 22, it says 225 sophomores watch TV, right? So again, looking at this box plot, we have no idea in terms of, like the quantity of people who do these things, right? So so this would be cannot be determined. Right? We can't answer that kind of question. And then 23 says twice as many sophomores watch TV more than 1 hour than do homework for more than an hour, right? So this one is true, right? Because remember, we already talked about the hour thing. Up here is 25% of the data, where for the TV time, above an hour is 50%. So in other words, twice as many, right? 25 times 2 is 50. Watch TV more than an hour than do homework for an hour. So that is true. Right? All right. So now I have one more worksheet to help us see the connection between histograms and boxplots. So I'm going to walk you through like how I think about this. So immediately I kind of draw my eyes to these outliers, right? So A, B, and C have these outliers to it. Only one has an outlier to the left, right, which is option C. So what I would be looking for is which histogram looks like it would have an outlier to the left. And, here that points me out that that's potentially an outlier, right? It's kind of, the shape makes me think that there's an outlier there. So 3 would actually match with C, right? So those already match straight across, right? So we got C taken care of. And then next, I have outliers to the right. So I want to think about which histograms would potentially have an outlier to the right. I would say 2 and 5, right? So I'm looking here and here. Those look to have outliers. So then comparing these two box plots A and B, notice A, the data is kind of, it looks smushed together. There's not a lot of gap in between. The data is kind of smushed together. Then the outlier is kind of further away from that, like the bulk of the data. Right? Where if we look at B, the data is not so smushed together, and then there's an outlier kind of closer to the data. Right? So by looking at that, I would say that 2 matches with A. Right? See how it's kind of smushed together here, and then there's my outlier kind of further away. Where 5, my data is not so smushed together, and the outlier is still, kind of closer. So I would match B with 5. Right? So we took care of those. And then now we're comparing 1 and 4. So one thing that I notice is if you look at 4, the data doesn't have as much horizontal spread to it, right? The values are kind of, kind of evenly distributed almost, in a sense, almost like a uniform distribution. So to me, that looks more like E, the box plot E. Or if you look at 1, kind of the bulk of my data is in the center, and then it's kind of, have more distance, more spread. So I would say that would be match with D. Right? So hopefully this was helpful, talking about box plots and answering these questions about box plots. So if you have any questions, make sure you email me or contact me. Thanks.